everyone, today our group would like to present the assignment of KMK1103 Discrete Structure with the title Permutations and Combinations. Our group members are Dennis Estella Lim Hui Geok, Lo Jia Yan, Muhammad Izzat Hakim bin Sebli, Semi Voon Sze Chee, and Tan Yen Vee. So now let's start. What is permutations and combinations? Permutations and combinations are methods to provide various ways to select the object in terms of numbers, alphabets, and items from a set. A permutation is known as a mathematical method that involves the selection of objects from a set to form its possible arrangement. In permutation, the selection order is accounted as important factor, while combination is a mathematical method that involves the selection of objects from a set to form its possible arrangement, and the order of the selection is not required. It means that you can select the object in any sequence that you prefer. Here are the formula of permutation and combination. The number of R permutation of a set with n distinct elements is denoted as P in the bracket n, R equal to n factorial divided by n minus R factorial. For the formula of the combination, the number of R combination of elements of a set with n distinct elements is denoted as C in the bracket n, R equal to n factorial divided by R factorial times with n minus R factorial, where n is the total number of elements in the set and R is equal to the number of the selected objects. So in this assignment, we will do the discussion about the application of the concept of permutation and combination in certain daily examples. We decided to choose one daily example from the permutation and another daily example from the combination. For permutation, we are going to help Sally to set up her phone PIN, which comprises of 4 numbers, to avoid her little brother Sam sneaks into her phone to play games. The PIN numbers are chosen from the set S, which comprises of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and the repetition of the numbers are not allowed. Thus, we need to calculate how many possible arrangements will be produced from the set. While for combination, we are going to help Madam Tan to buy the fast food from the economy store for her husband, Mr. Lim, and her son, Donald. There are 5 types of vegetable and 5 types of meats available in the menu. She would like to choose 3 types of vegetables for her husband as he is a vegetarian. Then she will choose 1 type of vegetable and 2 types of meat for her son. In this situation, we need to calculate how many possible arrangements of the food for her husband and son without considering the order of the selection. That's all from me. Now I will pass the presentation to Sammy.
Thank you, Jia Yan, for her detailed explanation on the previous part. Good day, everyone. My name is Sammy Voon with the metric number 76688, and today I'm going to briefly explain the motivation of our project. Why is it important for us to learn the topic of permutation and combination? The topic of permutation and combination is said to be playing an important role not only in the mathematical field, but the implementation of this topic in our daily lives has also brought us a lot of benefits. Therefore, the students are encouraged to study this topic so that they will know how many different outcomes there are in a particular or specific situation. So in this slide, we're going to be looking at permutation. By applying this knowledge in our daily lives, we'll be able to know how many different ways there are for us to arrange a particular set of elements or objects. So some of the examples which implemented the knowledge of permutation include the local combos as well as the 4 numbers. The arrangement of the numbers in a set of local combo is very important because there are only going to be a combination of numbers which will be correct for the local to unlock. As for the 4 numbers, the arrangement of different numbers will result in different 4 numbers. In this slide, we have combination, and by learning this concept, we'll be able to know the number of ways of selecting a particular amount of objects or elements out of a set. Lottery as well as ordering a set of meal are said to be some of the examples of combination in our daily lives. The arrangement of the food items within a set of meal does not matter, but the combination of different food items will definitely result in different set of meals. As for lottery, the players are required to choose 6 numbers out of 49 numbers, and the order of the numbers does not matter. Next, I would like to invite Hakim to continue the presentation. Thank you.
Hello, my name is Izzat Hakim, and I will explain about an article that we found on the internet. The title of this article is Teaching Permutation and Combination Using Playway Method. This article is made by Deborah Olufun Milayo Makinde from Department of Mathematics, Obafemi Awolowo University. This article explained that how permutation and combination could be taught using Playway Method. The Playway Method involves human activities such as seeing, hearing, saying, and doing, which can make students remember it easily. This article also states that permutation is the number of ways that n elements can be arranged in order, while combination is the number of ways the object could be combined. Following is one of the examples of permutation shown in this article. The example is how many license plates can be made if there are 3 numbers and 3 letters if letter or number could be repeated. The solution is any of the 10 numbers could be chosen to be the first, so there are 10 choices of the first number, and since repetition is allowed, that number could be placed among the remaining 9, giving the choice of the second number to be 10, and in the same way, the choice of the third number is 10 as well. Following the same procedure, the choice of the first, second, and the third letter will be 26, 26, and 26. Therefore, the number of plates to be made using the counting principle is 10 times 10 times 10 times 26 times 26 times 26. Following is one of the examples for combination shown in this article. The example is, suppose that instead of arrangement, we wish to form committees of k equal to 3 people from the original n equal to 5. How many such distinct committees are possible? Solution is, this time the reasoning is a little subtler. From the previous calculation, we know that permutations of k equal to 3 from n equal to 5 is equal to 5 factorial over 2 factorial equal to 60. But now, all the order permutations of any 3 people will collapse into one single unordered combinations because they are all the same. As example, ABC, as illustrated. So, combinations of k equal to 3 from n equal to 5 is equal to 5 factorial over 2 factorial divided by 3 factorial. In other words, 5 factorial over 2 factorial 3 factorial equal to 10.
Hello everyone, I am Denise. I will be sharing about permutation. Let's have a look at this scene. Sally would like to set up a PIN number for her phone to prevent her little brother Sam from using it. She wants the PIN number to have 4 digits. Each digit can be chosen from a set of numbers ranging from the number 0 to number 9. And she doesn't want any number to be used repeatedly. Now, Sam attempts to list down all possible PIN numbers. However, the list seems never ending. Sam wonders how many sequences of PIN numbers are actually possible. We can help Sam to solve this problem by using permutation because the order of PIN number matters here. For instance, the PIN number 1234 doesn't equal to the PIN number 1243. Next, let's have a look on how to solve our question by using permutation. The formula of permutation is n factorial divided by n minus r factorial, where n refers to the number of objects in a set. For our case, since there are 10 numbers in set S, n equals to 10. R refers to the number of objects which will be chosen from set S. Since we have 4 different slots to be filled by 4 different numbers, we will need to choose 4 numbers. So, R equals to 4. Now, factorial, noted as the exclamation mark, is the product of all positive integers less than or equal to a given positive integer. For instance, 5 factorial equals to 5 times 4 times 3 times 2 and times 1. Now, we can substitute the value into the formula. By solving the equation, we can obtain 5040. Hence, there are 5040 possible sequences of pin number for Stelli's phone.
Hi, my name is Yen Vee. Today I'm going to talk about the real-life examples of combination. The venue is Economy Rice Stall, where Madam Tan is trying to choose some food for Mr. Lim and Donna for lunch. Mr. Lim is a vegetarian, while Donna is a meat lover. Therefore, she's trying to choose from Mr. Lim 3 types of vegetables, and for Donald, 1 type of vegetables and 2 types of meats. The food options are as below. Therefore, how many possible combinations of food from Mr. Lim and Donald? For this problem, we are to use combination. The formula is n factorial over r factorial times with n minus r the whole thing factorial, where n equals to the number of objects in the set and r equals to the number of objects that are chosen. Factorial is the product of all positive integers less or equals to the number preceding the factorial sign. For condition number 1, 3 types of vegetables are to be chosen from 5 types of vegetables in the total. Therefore, n equals to 5 and r equals to 3. According to the formula, we get the answer of 10 possible combinations of vegetables from Mr. Lim's packet. For condition 2, we'll have 2 combinations since our selection is made from 2 different sets, vegetables and meat. For both sets, the total are 5. Therefore, n equals to 5 for both sets. 1 type of vegetables is to be chosen for the first set. Therefore, r equals to 1. For r equals to 2, 2 types of meat is to be chosen from the set of meat. To combine both sets, we are to use multiplication. Therefore, according to the formula, there are 50 possible combinations of vegetables and meat for Donald's packet.